Thanks. Thank you, John. John's a little bit of a legend around here, and it's just an honor to be able to now work with him. And so thank you so much for introducing me. Is that a little too loud, or is that okay? All right. Howdy. Well, you guys are good. You're going to be Aggies. That's a test. You have to be able to do that well if you're going to come to Texas A&M. And it's something I had to learn as an adult. So if you're learning it as a kid, that's really good. All right. So are you having fun yet? Okay, great. I was wondering if it's a little too early, but there's a great day planned here for you guys. It's a ton of stuff to see and do that's really fun. And hopefully we'll kick that off. We'll have some fun in here, too. I would like to start off by showing you who's on the space station right now. Actually, by the way, there's some pictures and stickers and tattoos over here for you guys if you want to pick them up after. So these are the guys who are on the space station right now. And I wish there was a girl in this picture. But there often is. Just so you know, there are girls in the space station. On all my missions, there was some, and so it's a path for everybody, potential path for everybody. One of the amazing things about this is it's Expedition 55, and how many people in this room are 18 or less? Wow. So there's been people in space your entire life. There's never been a time in your entire life there haven't been people off the planet living in space, which is really incredible. And when that was the day that passed Expedition 1, and that day passed without notice. Like the first crew was going up to the space station. It was a big deal, yeah. But no one made a big point of the fact that we were planning to live on the space station, for a very long time. And hopefully by the time, there's no one on this space station, there are other space stations and other people out there. But I thought that it was the year 2000. It was October of 2000. That's a really nice round number, 2000. From the beginning of the third millennium, that's the point at which we became a spacefaring species. And hopefully we never have a time again when there's not people living in space. And so now we're Expedition 55, 18 years later. And I was on Expedition 17, which may seem like a long time ago when you look at the numbers. But this guy right here, this is Drew Foystel. He just launched. He was my crewmate on my last mission and his last mission. We were together on the last mission. You'll see other pictures of him coming up, plenty of pictures of him coming up. And so I'm really excited about this crew because, like I said, he just launched. He's waited a long time to launch again. That's our patch. He's wearing our patch in that picture right there from the mission we were on together. And he just did a spacewalk the other day, which went really well. And they were putting some new communication, Wi-Fi communication antennas outside, fixing a camera that had been broken for a long time, and also replacing some hosing for ammonia cooling on the outside. So that went really well. That was the 7th spacewalk. The last spacewalk he did, I did with him, so you'll see some pictures of that. And one thing I wanted to point out on this picture, too, is these are all the countries involved. This was a huge international effort, and is a huge international effort. How do you think these are the 3 that just launched? These 3 guys were up there already. Anton is the commander right now. Drew's actually going to be the commander when these guys leave. So it's a rotation of every sort of 3 months. How do you think these 3 guys got up there? Does anybody who's under 18 know the answer?
They took a passenger plane that they piloted up to the space.
Okay, passengers took a spaceship, right? Passenger spaceship, yeah. Okay. Anyone know where that spaceship launched from? Russian, yeah. It was a Russian Soyuz. And so he's Russian, and he's American, Japanese, 2 Americans. But these three guys who just launched, 2 of them being American, just launched, on a Russian Soyuz from Kazakhstan. Since the president got elected, there's been a lot of rhetoric about how Russia is our enemy. They're also our friends. So I don't know how to negotiate this. I mean, they're frenemies. We're really counting on them, right? We're really counting on them. I mean, since the shuttle stopped flying, we've been flying with the Russians. We built the space station with the Russians and all these other countries. And we are partners. We're joined at the hip in space. We're joined in the hip on the ground. Every single day there's communication back and forth. There's people here, people there, making the space station happen. And we are really counting on each other in space. And, in some way, I asked one of the flight directors at NASA about this just a couple days ago. And I said, are people worried about, all the politics? And he was like, we're just kind of like, shh, don't tell anybody we're we're actually working together. We've been proud of working together for so long, and now we're kind of worried that if anybody pays attention at the, to what's happening at the lower levels, say, wait a second, we can't be doing this with them. But we've been flying with them for years, and it's a fantastic partnership. And I just have to say, one of the most successful things about the whole space station program has been the international cooperation. That's been one of the greatest achievements of this program. Okay, so let me tell you a little bit about the space station. So this was a really special moment, and I kind of want to start at the end. This was the moment I was on the spacewalk. That's me, actually. You can't tell, but that's me. And my crewmate is reflected in my visor right there, taking the picture. And we were on the last spacewalk of the last shuttle flight, and it was the last spacewalk considered the assembly of the space station. So it was random luck. It was just a lucky honor to be on that last spacewalk. And I got to go out first and come in last. So I got to close the hatch on that last spacewalk of building the space station. That was 36 shuttle flights. At that time, during that spacewalk, we crossed 1,000 hours of spacewalking time on building the space station. They're up to 209 spacewalks now. It was 159 at that time on the space station, but it was the last one for building it. And so you probably know what the shape looks like. You can see it there. Those are solar panels, those beautiful panels right there. This is a harder view to understand, but we're out on the truss looking back across. There's a solar panel right there. That's like the one on the other side. These are radiator panels. These are for cooling. They cool the space station. They run ammonia through these panels. And I'm up on the highest possible place we could climb to, and we knew this was going to happen, that we were going to install something up here, and we have to get a really wide-angle view and get this picture because the shuttle is there. It's the last part of the assembly of the space station, so the most stuff in space ever, in one mission. And after this point, the shuttle wasn't going to come back again. So, if the shuttle's not there, it'll never be that amount of stuff in space again for quite some time. And so we took this picture, and you can see the length of this truss is a full football field in length right here, including the end zones. And this is also a football field, but you can't tell because it's a wide-angle camera, so it's kind of compressed. But this is the shuttle nose over here, sticking up. The shuttle tail's down there. Back in the back here, this is the whole Russian part of the space station, but that's a visiting European cargo vehicle, a visiting European progress vehicle, and below there's some Soyuz vehicles. You could have 6 different ships visiting and leaving, from the space station at the same time. Anyway, it's a massive complex. We have at times 13 people working together up there at one time. Literally, if you tried to put it down here, on Kyle Field, you couldn't. You'd need 2 of them side by side in order to fit it on, on the ground, on the flat field. So it's an amazing place that we've built. Okay. All right, so I want to kind of go back to the beginning now. Does anybody know where that is? Excellent. Yeah, that's mission control. That's mission control a long time ago at the beginning. This is what I saw when I was growing up on TV. And my dad, I would watch this with my dad. The Apollo program evolved, and I lived in Canada, as you heard, and so we were just totally fascinated. And I remember my dad's fascination, really rubbed off on me. He couldn't believe. Like, who are these guys? How do they get that job? It's got to be the coolest thing in the world, And many, many years later, I had that job, and my dad never made it to visit, actually, unfortunately. But I had that job that we had talked about when I was a kid, which was sitting in mission control and being part of the mission. That was me at the time, Cub Scouts, I guess. And this is mission control now, and very similar, in that we still have the old one around. It's a historic national landmark. So the thing that inspired me was when I was a kid was watching that all unfold. But then we went to Florida on vacation. I saw the launch of Apollo 11. That's which one that is? Kids want to tell me? Yeah, the one where they went to the moon. Yeah, so I was there when I saw that launch when I was a kid, only 6 years old, and told my parents that's really what I wanted to do. If you ever get to see a launch, has anybody seen a launch? How many of you seen a launch in here? Quite a few. Yeah, it's an amazing thing. Do you agree? It's an incredible thing to see, and it's totally different than seeing it on TV. It's brighter, louder than you can possibly imagine. The first time I saw a launch from about 5 miles away or something, the sound that was building up as it was getting closer started vibrating in my chest so much I sat down because I thought it was going to knock me over. Now that's not always true. It depends which way the wind's blowing. But that was my first experience with it. I also grew up on Star Trek. And this was happening at the same time that the space program was happening. And I was a little kid, so I didn't know the difference, what's real and what's not real, and thought, hey, exploring the galaxy sounds really cool to me. So I'll get back to that in a bit. So fast forward many, many years. I'll skip a lot of stories. Oh, okay, well, no, this is supposed to happen apparently a few times, and it's supposed to come back. All right, it came back. So this was our first. So this is when I was selected. So skipped a lot of years there. And I'm in the back corner right here. So this is the first day on the job as an astronaut. But something happened right before this day, and that was I came back from a trip, and there was a particular movie that was about to play, and the movie included a whole bunch of stuff about astronaut training. I was like, I can't go start the job without going to see this movie. Do you guys recognize this movie? Oh, it's Armageddon, right? If you don't right now. And so these guys are rescuing Earth from a asteroid that's going to destroy the planet. And this movie is really, I love this movie. But it had all the astronaut training stuff in it, and I had to, so I went by myself for the midnight showing, the day before showing up on the job, because I couldn't go do this until I saw this movie. And so something happened in that movie, though, that's kind of funny. It has to do with the Russians, and it has to do with some things that happened to me. So I'll want to show you this scene.
Come on, boys, come on.
Blow the bomb, Harry. We're with you.
It's stuck, yes?
Back off, you don't know the components.
Components, American components, Russian components, all made in Taiwan.
In Taipei.
I know how to fix it. Please move. I have to take you away if you don't move.
What? You gotta get that shuttle started. You gotta fire it up now.
Damn it, Chef! Get off this back! I'm telling you, please move! This is how we fix problem in the Russian space station. Stay here, and it's all right. Yeah, finally, we can go home.
So you know why I love this? Because it's kind of true. No, it's not really, but there was a day, though, that I was told it was a sticky valve that I was dealing with, and someone told me, hit it with the wrench. Mission Control said, hit it with the wrench. Say again, Houston. Hit it with the wrench. And I said, harder. I kept hitting it harder and harder. So, this actually happened. All right, so the training to be an astronaut is a lot of fun. How many of you guys have been camping? Kids, camping, yeah. My son is camping right now without me, so I'm gonna right here after here. I'm going to go meet him. This is, it's survival training, kind of like camping, except the funny thing about this was, there's a thing called SEER school. How many of you guys know what SEER school is? Tell me if I'm saying it's survival, evasion, rescue, resistance, and escape, right? Maybe not in exactly the same order. So this is, military training for survival. And, we're doing this for astronaut training, with the idea that if we're off course, if we land in the wrong place, we have to survive until rescue forces find us. We need to be able to survive in different environments. And also this is teamwork under stress, and that kind of training. But the funny thing was, they keep telling us, how when you cross the road, you've got to cover your tracks and how to hide your camp. And it's like, you don't understand. We want to be found. We want to. If this happens to us, we want to be found. But we do a lot of survival training, water survival training, because we're going to be flying in the NASA T-38s, the jets, which you'll see in a second, in case we have to bail out, eject. This is zero gravity training. You guys know the name of the zero gravity aircraft? Yeah, the Vomit Comet. Yeah. And eventually, it doesn't feel that way. But at first, it certainly does. This is survival training, shuttle training. It was possible with the shuttle that you could actually bail out of the shuttle. If you knew that the shuttle was not going to be able to make it to a runway, we would bail out of the shuttle, and we had the ability to parachute down to the ocean and have rafts and things like that. There's some of the flight training, and then the T-38s that we fly. And the reason we did this, it was very important because, as you can imagine, that all the things that we practice for to do in space, we can't do them on Earth. We can try to simulate them in different ways, but everything we do is a simulation. And and the one thing we do that's not a simulation is this. This is a live environment, with real-time decision making that have real-world consequences, and there's and your safety depends on your actions, and things can go wrong. So this is in a sense real-world spaceflight training. So we call it spaceflight training readiness or something like that. And then we do other kinds of training, especially for long-duration missions. This sort of has come up as we were building the space station, realizing that flying in space for a couple of weeks, you can put up with anything for a couple of weeks, or anybody, right? But if you're going to be in space for 6 months, it's a little different, and it's different. It's more of a marathon, right? And so we do these different types of expedition training exercises. Basically, go out into environments that are very stressful. Take turns being team leads, basically, and they keep making the situation more and more difficult for us. And so this was northern Canada. This was about 5 hours north of Edmonton, and they dropped us off by helicopter in the middle of nowhere. And this is not the middle of nowhere. This is before this is when we came back, actually. And then we're out in the woods, pulling the sled around. It's usually 20 to 40 below zero the whole time. And then they make bad things happen to us, and they don't let us ever sleep. They keep giving us instructions. We're going through a blizzard in the middle of the night. We set up our camp. We were just about to rest, and then the radio call says, "Okay, you just set up your camp. Take down your tent and move to these coordinates." Oh, you got to be kidding me! So a lot of things that just stress you out. Make it very hard on the team, and to find out where your weaknesses are. You do the similar thing in Russia. This is survival training if the Soyuz lands off course and you're in Siberia. It's winter survival training we have to do. We also do a water survival training in Russia. This is, if you land in the ocean with the Soyuz capsule and you possibly might have to get out, or there may be a fire, it may be sinking. And it's kind of a hazing exercise in a way because it takes about 2 hours in there for 3 people in these really cramped conditions to change into a water survival suit. And so it's hard to kind of figure out under what situation it's urgent to get out of the space capsule, but you have 2 hours to change costumes. So we can't figure that out, but the Russians do it. It's like you have to get through this, otherwise you're not qualified. And then there's, of course, training all over the world, simulators. This is in Russia, Soyuz simulator and the space station simulator, and under training for spacewalking and so on. So lots of training. My first mission was this one here. It was a shuttle flight. And I don't know if you can tell, but that you can recognize the commander is Mark Kelly. Do you remember Gabby Giffords? His wife was shot a few years ago, well, just before this mission. Actually, the next mission, you'll see in a second. And on this flight, we brought up Japanese, this is a Japanese flag symbol. So we brought up the Japanese experiment module. It's the most beautiful research laboratory we have on the space station, the biggest, the most beautiful. And they had the benefit of putting that on after we had learned all the lessons from the modules that we had put up. And so it's a spectacular science facility. And then they left me on board, so I was the first one to kind of work with the Japanese module and all the other research modules and get them all working and test out the science program. I left me on board with these 2 guys. So these are 2 Russians, Sergei and Oleg. And so, with my last name, which is Chamitoff, you might just think 3 Russians were on board, But I had to be the Japanese astronaut because I was, unfortunately for Japan, they didn't have a Japanese astronaut on the first mission with their module, so that was me. But the funny thing about this was that none of us had flown in space before. So there's a $100 billion space station up there, and they sent 3 rookies to take care of it. So the next thing was my mission rolled over into Expedition 18. So I was with Mike and Yuri when they came up, and the other 2 guys I was with went down, and then I left, and then these 2 came on different rotations during that as well. Then I finally went down on this shuttle flight with that crew who came up at the end of my 6 months. So that's kind of the that was one of my first, and that was a 6-month mission. So the next mission was, and there's Mark Kelly again. So I got to fly with him twice as commander. So when I landed in the shuttle, it was the smoothest landing I've ever had on any runway in any plane. And I don't know whether to blame it on the shuttle or Mark or the commander. I don't know. It's probably because of him. But there's Drew, I showed you at the beginning. And Drew and me and this guy, Mike Fink, we were the ones who did the spacewalking, and also we called him Box. Everyone has a nickname. In the military, everyone has a nickname. So the box, and I did the robotics to install some things, which you'll see in a second. This is, speaking of the nicknames, so his nickname was Spanky. And that was a dangerous nickname. Because it's just spank me, spank you, spank a lot, spank. It just went on and on. And there's an Italian astronaut on our crew as well. All right, so, one more mission that I went on. Does anyone know where that is? So, yeah. That's right. I finally went on the Star Trek. So this is the Star Trek bridge. And I got to sit in the captain's chair, so Captain Kirk's chair. And actually, we flew this phaser. That's a Star Trek phaser. We flew this for Paramount as like a part of a STEM thing with Paramount, so I got to bring it up on our flight. And then I went and gave it back, and I got to go on the set. And there's J.J. Abrams here, and I'm handing him back the phaser, and he's trying to take it from me, and I wasn't letting it go, because I love that thing. All right, so I want to show you a quick video of what it's like to be in space. This is from my last mission, and then I'll talk more about what it's like to live and work on the space station.
Endeavor. We want to thank all the tens of thousands of dedicated employees that have put their hands on this incredible ship and dedicated their lives to the space shuttle program. As Americans, we endeavor to build a better life than generations before, and we endeavor to be a united nation. In these efforts, we are often tested. This mission represents the power of teamwork, commitment, and exploration. It is in the DNA of our great country to reach for the stars and explore. We must not stop. To all of the millions watching today, including our spouses, children, family, and friends, we thank you for your support.
It's a final countdown.
Okay, ohms burn starting in 5 seconds.
Oh, now.
Here we go.
Spectacular ride. I couldn't see anything but the lockers, but it was still a lot of fun.
No master alarms.
I'll have to say it was a lot different than flying on the Soyuz.
We've so many lights to go, and things could be.
You're upside down.
Hey, didn't I see you up here last time? You were upside down last time, too.
You're still upside down.
Oh, you're upside down.
It's a final countdown. The final countdown. The final countdown.
All right.
You guys look great. You know why I'm wearing these? Because it looks cool.
Hey, I've got a pair of those. Yeah. Hey, I want that experience.
Have some Fiesta chicken. That's the best stuff.
In Houston on the big loop, we're tally-ho with the station. Initiating RPM on my mark. 3, 2, 1, mark. Houston and station, capture is confirmed.
Never arriving.
D-Mod. Welcome to the station.
Daring us to dream of places far away inside. Your light inspires all, unleashing soul's desire. Our world eternal loves the changing faces that you wear, reflecting back to all.
For the OPS standoff, use a very ultralight ninja graceful ballerina grip, as we talked about. EV2 is ready with ninja ballerina grip. In behalf of the STS-134 crew and the Expedition 27 crew, space station assembly is complete.
This space station, the pinnacle of human achievement and international cooperation. And now it's the brightest star in the sky and hopefully the doorstep to our future.
Is a blue.
It's a pleasure serving with you boys. Go Navy.
Up through the stony ground, there's no room.
As we come up on about our 200th sunrise of the mission, we can clearly see AMS now on station and ELC-3. And I just want to congratulate the whole team on the ground and the Expedition 27 and 28 crews for all the hard work that you guys have put into this. We're the ones that get to see this incredible view. But, you know, you're all with us in spirit, and this is really a new day for science aboard the space station. So thanks to all of you.
It's a beautiful day. The sky falls, you feel like it's a beautiful day. So let it get away on the road.
Houston, Endeavor, runways in sight.
Copy, Endeavor, runway in sight. 122 million miles flown during 25 challenging space flights. Your landing ends a vibrant legacy for this amazing vehicle that will long be remembered. Welcome home, Endeavor.
Doesn't ring true. You've been all over, and it's been all over you. It's a beautiful day. So let it get away. It's a beautiful day.
Houston, Endeavor, we'll stop. On behalf of my entire crew, I want to thank every person that's worked to get this mission going and every person that's worked on Endeavor. It's sad to see her land for the last time, but she really has a great legacy.
See the world in green and blue. See Chandler right in front of you. See the canyons broken by.
What do you think? Yeah. Okay. Does anybody want to go? If you want to see Endeavour, she's in the California Science Center in LA. Very, very hard for us to see that spaceship in a museum because there were 25 flights on Endeavour, and if you were inside it right now, it would look brand new. It's in perfect condition, and we had to retire it, to kind of move on to the next program. But there's been a long gap, between having U.S. vehicles to fly in space. Okay, so I want to tell you a little bit about living and working in space, this is what happens when this is what happened when the shuttle would leave. I don't know if you guys can see. I'm kind of standing in their way. That's a hatch over to where the shuttle is usually parked. And this is back in the Russian side of the space station, very busy place. You can see forks and knives standing vertically on the table over here where we just put tape down and we just stick them on and they just kind of float around like that. And that's how we leave our stuff on the table. This is coming out of the Japanese module. Like I said, the biggest module. There's a storage area there. It's a fantastic facility. On the other side there was the European research facility. And I'm turning a corner now into U.S. lab. That's an interconnecting node of the U.S. This is the U.S. laboratory. This is where our science is done. And then going back into another interconnecting node, which has many things on it, but there's a spacesuit, and if you go to the left there, that's where the airlock is. We did our spacewalks from. This is now in the Russian side of the space station. Those are urine containers, and they're all full. Okay, we'll get back to that in a minute. And then this is back now in the Russian side of the space station, where that's sort of their command and control center. That's where they're sleeping, or we had our facilities for all our facilities for bathroom and cooking and everything. We would sleep in these little sleep stations. There's just enough room in there to like Velcro yourself to the wall with a sleeping bag, have a computer in front of you maybe, and keep your stuff in there. And of course, we had to do a ton of exercise every day to maintain bone and muscle mass, right? You know that you lose your bone and muscle mass in zero gravity. So we do aerobic exercise, we do resistive exercise, sort of like a cable machine. And we can run, but that harness has got to be on really, really strong bungees pulling you down. So it actually really hurts your shoulders. It's like your whole weight, as much as you can get of your whole weight, pulling on your shoulders to pull you down on that treadmill. Everything else that you do in space, it's kind of like camping in a way. You do it a different way. You have to figure out how to do it, and you get very good at it, very fast after a while. And you have to, trust your crewmates because for 6 months you're probably going to get your hair cut, and they're the ones to do it. So Sergey and I were each other's barbers, but Oleg wouldn't trust anybody with his hair, and you'll see the result of that right here. You also have to follow procedures really, really carefully. These are Russian procedures, and they're for the bathroom. So if you don't read Russian, you're kind of in trouble. We would spend our Friday nights oftentimes watching some movies. My Russian crewmates had never seen Star Wars, and they had never seen any Star Trek. So I had a lot of work to do to educate them. So we did that. And if you have a little bit of time and a little bit of space, everybody is an acrobat in zero G. And you never want to pass up a Superman opportunity. I played chess in space first against the mission control centers, and they had to take turns moving. And that was a handicap that Japan made a terrible move because they don't usually play chess. Russia was really upset, and so I won that game. And then I played these third grade chess champions for the U.S., and they killed me. So that means if the third grade kids beat me and I beat mission control, the third grade kids are smarter than everybody in mission control. Right? There's the guitar that John mentioned. Actually, I brought up the strings for that. The chess was a thing that I did for the first time. And these are my kids on a live kind of Skype session, and I get to talk to them about once a week and have an interactive session with them. Could make a call, every night, but I could only have a two-way thing once a week for about 15 minutes. So that was tough with small kids. Okay. So what are we doing up there, especially now? Now that the space station is complete, the purpose of the space station was to do, science in space, and the environment there is, take advantage of the environment, which is very, very different than here. And it's the only place where we can, have that environment to work in. One thing for sure is observations of the Earth. And, there are other satellites and things, obviously, that are taking observational data of the Earth, but the space station's got a unique perspective. It's low altitude. We get oblique views, and you have the human eye to notice things and take pictures of things. And there's a lot of sites around the world that we're tracking because the changes on the planet are really obvious from space. They're obvious to the naked eye. So whether you believe that, whatever your beliefs are about the reasons for the changes, the changes are happening, and we see them really, really clearly from space. So we track these certain places and kind of run to the window with the camera, whenever we're flying over something that is worth grabbing a picture of for science reasons or otherwise. And astronaut photography has been a big boon to understanding what's going on the Earth. Let's see if I can get this to change. Hold on a second. I see the problem. Just give me a second here. Got another thing that popped up on me. This is not good. Yeah, where's the wrench? Okay, let's see if we can recover from that. Okay, all right, let's hope. Okay, so the other thing is space science, right? You have a fantastic vantage point for looking up, for looking out. And one thing that we brought up on our mission, the one that you just saw the video of, what happened? I was going to go through. Yeah, hold on a second. That's all right. So this thing right here is called the alpha magnetic spectrometer. It's a $2 billion cosmic ray detector. And we brought that up on our last mission. It's the most expensive science experiment we have on the space station. And have you heard of dark matter and antimatter? It's trying to study dark matter and antimatter and understand origins of the universe. We installed this on top of the truss with a robotic arm. And that's a pretty expensive thing to be moving around. And I was working the robotics on that, and the commander was standing over our shoulder, like holding his breath. And he was very happy when everything was connected and working, and it wasn't his responsibility anymore. But that's been working fantastic and gathering amazing data, trying to understand the universe. Microgravity Science is the main thing we're doing on the space station, and there's a lot of stuff going on every day. Probably about 150 experiments at a time running during a mission. Especially now, we had a 6-person crew working all the time. And the thing to realize is that the zero gravity environment affects gravity affects everything. I mean, we're so used to it here, you don't think about it, but it affects everything, and things I wouldn't even have imagined. For example, how does a virus or a cell in a fluid know that there's gravity, or care? That they're in a fluid moving, or why does it matter how much gravity there is? But we're finding that genes express themselves differently in microgravity, and we don't really know why. But we can detect that change, and then we can actually take advantage of it and use that to create an antivirus. So this is actually salmonella, and there's something like 50 genes that express themselves differently in space, in zero gravity. And we've been able to use that to develop vaccines. Things like flame, very different, because you don't understand when a flame is burning, right? The air gets hot, and hot air is lighter than cold air, so hot air rises, right? And then cold air comes in to fill in, and it creates convection, right? So we know this convection that we see all the time with a flame. Well, in space, the hot air and cold air, it doesn't matter. Without the gravity, it doesn't matter, whether it doesn't cause a convection. And so a flame just burns all the oxygen around it and then puts itself out. And nothing else comes in. And so there's some very interesting experiments with combustion science we've been doing to try to get complete combustion and get rid of some of the products of combustion that cause pollution. We've been able to make some interesting progress with that. Fluids, obviously fluids behave well with gravity. They pour, and you know what to expect with fluids. Without the gravity, there's wicking properties, of fluids, how they behave and when they're attaching to a surface. One of the astronauts invented a coffee cup for space, which is kind of neat. He basically folded a piece of material so it has one edge, one corner, and you can put coffee in there, and or any liquid in there, and it just keeps filling up it just wants to wet the surface of that corner. So as you drink, it just keeps filling up that corner, and it keeps coming up that one edge. So we're thinking about ways to make pumpless systems to move fluids around in space, taking advantage of this capillary action, surface wetting properties, stuff like that. A lot of materials and investigations outside the space station. What happens when you put things in the vacuum and the pressure and the exposure to radiation and all that outside in space? Things like that you'd want to use to protect you, like put on your suit, put on a spacecraft. But also more complicated things like circuits, like how are circuits how well will they survive the radiation environment? Plant seeds, how will plant seeds survive the radiation environment, and possibly the thermal extreme? So we put all kinds of things outside and see how they react to figure out, what are the best seeds, what are the best crops to carry in space to grow things that are more resistant to that environment. Of course, we're studying human physiology because we want to understand how to survive better ourselves in space and be able to thrive when we go off back to the moon and Mars and so on, and growing things in space. Interesting that, so during my mission, the Russians were growing this, we ate it, and then I don't know how many years later, or 5 years later, I think you'll see, they were advertising the first ever plants were grown in space and eaten by the crew. Really? We did this 5 years ago. It was a Russian experiment, not an American experiment. So somehow they seem to forget. Okay, so yeah, and here's some of the things that are going on now. This has to do with trying to figure out how to build a greenhouse in space so we can provide food for ourselves when we go to the moon, Mars, and long transit distances. I mentioned something about the flames growing. There's also growing food, obviously. Haptics is very interesting because when we go to Mars for the first time with humans, it's going to make a lot of sense to have someone in a base or in orbit controlling robots on the surface and exploring. Because it's very hard to teleoperate robots from here because there's a huge time lag, a 4 to 20 minute time lag in the signal getting to Mars. But if you're in Mars orbit, controlling robots on the surface, there's very little. There's no, it'd be like, here to the space station, very, very close in terms of radio communication. And so we could be driving robots and doing science all over the surface and figure out where should the humans go, right? And so teleoperation of robots from space or from distant locations, that's part of this experiment here. Some stem cell experiments, and then more human physiology. Like I said, there's 150 experiments going on. I just sampled some of them. If you just go to nasa.gov and poke around, but you'll find research pages there that will tell you all about all the experiments that are going on the space station. So there's a whole other category that I like to call engineering science, because all the stuff we put on the space station is new. Like all the systems are new, that they've never worked in that environment before. So the whole space station is an experiment. How do you live and work in space? Life support, scrubbing the carbon dioxide out of the air. This is about, that's what that is. It's a carbon dioxide removal system that I had to take apart and put all back together one day. It was a 9-hour job to replace a filter. This is funny. I love this picture because the crew that picked me up for my long duration flight, they brought up a urine processing system. So for the first time ever, urine was going to be processed and turned into drinking water, right? So that water would go into your food and it'd be into your drinking bags, and that's what you would be drinking. And so they're very happy because this is today's coffee and yesterday's coffee, right? All right, so the first ever recycling of urine in space. That's it, right there. And these are the 3 guys who came up and brought up the processor and were picking me up, and I was going down with them. That's Mike. That's Spanky, right? Spanky was with me, and he knows something that they don't. Well, they know, but he knows something. The reason he's smiling is different, because he knows that's his pee and my pee, and that is the bath. So, and these guys are drinking it. So. Another experiment that I really loved in space was this one. It's called spheres. It's these robotic spheres that fly around inside the space station. You can test out things like rendezvous and docking algorithms. It's basically programming robots in space. But I want to tell you more about that because I got so excited about these robots because I programmed them on the space station with some stuff that was of interest to me research-wise. And I went back. MIT built these things. And I went back to MIT and I said, we could turn this into a competition for high school kids and then also middle school kids even. And so they did that. And in a number of years, on my next flight, we were able to kick off the competition from space. And now kids all over the world are programming these robots in competitions. We just had the finals in January, world finals in January for this last round. And so there's teams in the US and Russia and Europe and Canada, Australia, Mexico, Israel, Japan, all programming these robots. And the cool thing is you program them, you get some kind of, it's kind of like the first robotics where the robots compete against each other to do something. So you could be cooperative or you could work against each other. And it's done in simulation at first, but then teams and alliances are formed. And then the winning alliances actually get to fly them in space. And so there's a day at the end of this event each year, actually twice, once for middle school and once for high school, where there's a live link up with the crew on board the space station, and the crew is flying the kids, students' robot algorithms on board, and the competition happens live on board with interaction with the crew. So it's really, really exciting competition. We're actually running it here for Texas, for middle schools. We're sponsoring that here, and so the middle school teams are able to apply right now for this next summer, and high school teams start in September. So this is a lot of fun. So I wanted to show you what happens when we're not working. I mean, you can imagine we're very busy up there. We're working every day, but we have a little downtime. I want to show you a little what happens when we have time to fool around. Those are those Swedish fish, you know those candies? All right, there's a little overlap, but I had to show you the rest of that. Okay, so what's next? Some of you may know about, anyone see the SpaceX launching a Tesla into space? Yeah, that was pretty cool, wasn't it? Yeah, so several companies working with us to do commercial spaceflight operations, basically to enable us to launch again, have humans launch again from the United States, not just Russia. And so we're working with SpaceX and Boeing, and then this is a Sierra Nevada's design that we hope will someday be actually flying to, and this is the Space Launch System. This is going to be the biggest rocket ever when it's ready to go. This is going to allow us to get much more mass up in space, to be able to go further and bring more, resources with us to go to Mars and so on. Obviously, we want to go to Mars. We want to go back to the moon. That keeps changing back and forth, which is the favorite option. Just go straight to Mars or spend time at the moon. The current plan is to go to the moon first and build up our experience and do our operations there. Try to do everything on the moon that we could possibly do in parallel to what we would do on Mars. And in fact, the students here at A&M in my class, in my design class, are trying to design a moon base to parallel all the things you would do on Mars, so that as much as possible the hardware is the same, the procedures are the same, and we can actually practice them on the moon when we get there. This is some concepts of Mars cities that are more futuristic, that are as part of a Mars city competition. And NASA's plan is to build something called a deep space gateway. I think they just recently renamed that, but I like this name. And it's not really in lunar orbit, but it's closer to the moon. It's in an orbit. There are some things called libration points. They're kind of like balance points in the solar system. And this orbit's one of those balance points. And the balance point puts it pretty close to the moon. So it's a high energy place, which means from there it's easy to get to Mars. It's easy to come back to there from Mars. It's easy to get to the moon and back there from the moon. And so we want to put a base there. It's out of the Earth's magnetic field. It doesn't have the protection the space station currently has, so we can practice really doing things in deep space and using that as a staging ground for where to build a transit vehicle that can take us further out, take us to Mars, to asteroids, and so on. And so any operations we do to and from the moon would be from the Deep Space Gateway, and we would use resources on the moon to fuel the vehicle that we would build there to go out, Mars and further. So that's kind of what the plan is. So let me tell you a little bit about what we're doing at Texas A&M. This is my lab in particular. We're doing a lot of things in space. I'm just going to tell you about one thing that's going on in my lab. We're building this thing called Spacecraft. You can sort of see the idea, engineering humanity's future in space. But the main thing is, this is a platform online that we're trying to build to let everybody contribute to the future in space. Right now, it's pretty hard for you, if you have a great idea, to go to NASA and say, hey, NASA, I got this great idea. Can you give me $1 billion to build it? Well, it's kind of hard to get that, right? And especially for people in other countries all over the world who have fantastic ideas, they don't have a way to collaborate. And this is a virtual reality collaboration engineering platform. So you can design things in engineering. You can model them in 3D. You can write algorithms to control them, like AI algorithms and things like that. And you can put it in VR, and you can interact with it as part of a mission. So somebody can build the spacesuit. Someone else can build a habitat. Someone else can build a rover. Someone else can build a tool. And we can meet in virtual reality and go use these tools and try to execute the mission the way we're actually going to do it. And so these are what you're looking at here is graphics. But all the math is behind this. The C state here is a mathematical model running, and the buoyancy on the capsule is math. So all the math is in there, the physics is in there, the engineering is in there, and people can use this platform together to collaborate in space. So we're doing this with NASA. They're advising us on this, and NASA wants to use virtual reality to evaluate future missions. It's kind of, given the technology we have today, it's hard to imagine that you would plan a mission to Mars and you wouldn't experience it 1,000 times in VR first, right? To see, hey, does this really work? And so that's what we're building, and we're just about to put it online for anybody to use. So that's what we're excited about that. So I want to end with this picture. This is one of my. I have to say, this is probably my favorite. I took 22,000 pictures in space, and this is probably my favorite one. And I don't know if anybody can turn the lights off at all for a second. Is there a light switch over there anywhere? Do I have them? Find out. But, this was a view. This is a view outside the Japanese. Oh, great. That's good. That's great. That helps. Well, let's do it. Now you can really see it. This was a view outside the Japanese experiment window. And I went to that window every single night before going to bed, and I just stared at this view. And it was very, very hard to rip myself away and go to sleep, because this was the view from the space station. And I know that we've all seen Star Wars movies and incredible views that look just very similar to this, in science fiction. But this is real. This is really what it looks like up there. And for 6 months, I went to this window every night and stared at this before going to bed. And the feeling that I have when I see this now, and then, is this, it's not a matter of if, and when. We're already in space, and we're there in a big way. This is a massive space complex that's, that we have in space that we've built together in all these different countries. And we have a fantastic opportunity right now to take our species out in the cosmos, and explore all these places out here that there are to explore. Starting with the ones that are closest in our solar system. We have a fantastic opportunity to make this possible. And you students that are here tonight, you guys that can have the opportunity to become physicists and engineers and be the ones to make that possible. The space station right now goes in circles around this globe and can't go any further. But when you look out this window and on this massive complex, you know that we are already there. We're already in space. It's, and I don't want to see us lose the opportunity for our species to continue that evolution because something bad happens, and politically or something, and all of a sudden, the opportunity goes away. So this is our time. This is our time to make this happen. So I really encourage you guys to study hard, go into STEM, fields, and come to Texas A&M and help us, make this happen. So, all right, thank you. Okay. 5 minutes for questions? Yeah. So, yeah. We have a few minutes for questions. We have 5 minutes for questions if you. And I have photos up here. Please, if you're gonna stay for questions, please, sit down. Yeah. Okay, please. Yeah.
What is the hardest part for you working on the ISS?
So the question is, what is the hardest part for us being on the ISS? So actually, the hardest part really was being away from my family. That was the hardest part. But there's a lot of people who have to work in different places around the world and be away from their family. But that really was the hardest part. Yeah. Yeah. So the question is, how hard is it to get used to the zero gravity? Guys, please don't come up and grab the pictures now while we're doing okay, it doesn't matter, whatever. Okay, never mind. I'm just trying to keep some so everybody can hear. But, okay, hold on. So how does it feel, going to zero gravity and adapting to that and coming back to 1G? It only takes about a day. Everyone feels a little sick when you get to space for the first time. But the nice thing about it's not like a roller coaster. A roller coaster, you're up and down and left and right, and you keep getting pulled different ways. But when you go up to space, you have all this acceleration on you, 3 Gs, 3 times the gravity pushing on you, but then suddenly it stops. And then it just stays that way for as long as you're up there. And that helps. So it doesn't feel good, but within a day, you're fine. Coming back is much, much harder because you're not used to standing, you're not used to sitting. And gravity feels really, really strong when you get back. And so you're dizzy, and you can't walk, and you can't sit. And your back has stretched out, and it starts to compress, and that starts to hurt. And so we have like six weeks of rehab, rehabilitation. We come back to help us, get back in shape. Even though we're exercising 2.5 hours a day in space, you come back to gravity, and you go, wow, this is gravity's. We have expressions. We say gravity sucks. Another question was over here? Yeah.
Between the intellectual, physical, and moral training, what was the hardest part?
Well, the question over here was about what's hardest in space, and and I mentioned my family. That is really one of the hardest things. But I think it's. What's hard is that every day you're at school, you go to class and you get homework and you do work and then you have other activities and you go to bed and you have a routine, right? This routine in space is, you saw the little closet we sleep in, right? Well, that's your home. You come out and you're at work. And that's the only thing you can do there is really, the time is really valuable, and so you want to get things done. And so you're always working. And the schedule that you have has a little red line that moves along, tells you what time it is and what you're supposed to be doing right now. And you're always behind. You're always panicked, because it's always moving away. And so one of the hard things is to do that, to continuously be doing that for 6 months. Where it'd be really nice if you could say, can I just take one day off, go somewhere else, and come back and then start again? But you can't. You're there for the entire. You're there as long as you're going to be there, and then you're done. And so the hardest part is psychologically is just to keep working every day have a good attitude and be nice to everybody on the radio, and and even though things work and don't work, you have be positive and do that continuously for 6 months, and then you can relax. So that's really hard. Yeah.
How do you get selected for training?
Question is, how do you get selected for training? That's a good question. So you have to do really good in school. Are you doing good in school? Good. Okay. So you have to do really good in school, and then once you have your degrees from college, then you can apply to NASA, and it helps if you have some work experience. All right, and there's also a lot of different skills and things that you could learn, like scuba diving or flying or speaking another language, international, some travel. There's a lot of different things you could get exposed to in your life that help, make you a good candidate for it. But you actually can apply online, and NASA does a big selection, and you can imagine the kind of things that NASA is looking for, right? They want to see that you are really dedicated, that you're really passionate, excited about the things that you do, that you do well at them, and that's pretty much it. The other thing is, in the final test, they want to see it. They'll talk to you and they'll say, I know that you're smart and I know that you're capable, but do I want to spend 6 months stuck with you in this small space? And if they answer that as yes, you're hired. Okay. Yeah. Superfluids with interesting. Yes. So one thing I did in one of my experiments, it was using it was a fluid, and the fluid had long chain polymer molecules in it. Right. So these are basically long molecules, and there was two different. So imagine two discs and a ball of water between them, okay, or fluid between them. And if you pull those discs apart, the fluid would just fall, on Earth. But in space, they just kind of they're sticking to both ends, and they're making like a tube between them, right? And that fluid had these long chain molecules in it. And so what we'd do is we'd spin up one end really fast, and those molecules, as small as they are, would get tangled up with each other. And then the fluid, which is just like, so imagine a fluid you could pull on that pulls back. And we're basically testing how that fluid would, behave in tensile strength as you'd spin it, as the molecules would be tangled and then get detangled. So that was a Japanese experiment that was like that. So that was very interesting. Yeah. Humanoid robots. Yeah. There's a robot on the space station called Robonaut. And Robonaut is, it's a really amazing kind of development platform. I mean, one day I'm hoping that, and in the programs that I told you, the Spacecraft, the thing we're developing so you could collaborate in space, we're actually programming robots in VR. So the robot design is in VR, and we're programming them in VR. We have robots moving around virtual worlds and exploring and navigating by themselves in virtual reality now. So we're doing that now. The ones on the space station weren't quite ready for that yet. And so, unfortunately, when I was there, Robonaut was sort of in a closet. And, and Robonaut has got hands and a head and a body. And I had to do some work up there to replace something. And Robonaut was right in the right space. So my interaction with Robonaut was to get him out of the way, do the work, and put him back. But I didn't actually get to do anything useful with Robonaut, unfortunately. But they have after that. After my mission, they certainly have. Yeah. Yeah. Question is, what is it like sleeping without any gravity? It's the best sleep in the world, and I wish I could go back and sleep there. It's because there's no twisting and turning in the sheets. Everything's floating, and you're in a sleeping bag, and a sleeping bag is you kind of Velcro around it to kind of keep you where you want to be. The thing that's weird is that we're so used to putting our head on something when we sleep, and it's hard to sleep without that. And so what we do is we'll put a Velcro strap in front of our head, and you can sort of lean into that, and so you feel like you're against something. At first, people have some back pain. It helps to get in the fetal position, when you're sleeping. The really funny thing about sleeping, though, is that your natural body position is not like this, right? If you're floating, and you can see it in all the videos, if you just watch somebody in space, they're kind of like this. Their head's a little back and their arms are a little bit up. And so you fall asleep, in front of a wall with your stuff, your flashlight and whatever, your light. And you fall asleep, and by the time you wake up, you're like this, And then you're reaching for stuff and you can't find anything. And occasionally that something will happen. Like in the middle of the night, you'll feel something crawling on your face. And what the heck is that? And it's your own hand hitting you in the face. So, let's get somebody who didn't ask over here. Well, I did 2 launches. In the first launch, I was there for 6 months. And then I did another one, which was about 2 weeks. Yeah. Do we have to wrap it up? Or are we good?
I think it's about time to stop. Thank you very much.
Yeah? Okay. My pleasure. Thank you.